So for question 3 and 4, which is the same kind of thing, we'll do a query first and then turn it into a procedure. This is actually a very interesting time we can talk about something. It's maybe a bit more an advanced topic, but I think it's worthwhile discussing. We have multiple joins involved in this query. Now I know this isn't the first time you've been presented a challenging query with multiple tables that you have to get all the joins right? But this is an interesting one because there are different approaches. Some work and some don't, right? In terms of the joins that you select to use. So if we just think about it, this is well, I've got it written here in the instructions as well, but what we need is the combination of data. What we want is inventory ID, description, color, size, and so on. These are all fields from the inventory table. Inventory ID, description, color, size, etc., right? But we also want to show the supplier name, so there we go. That's in the supplier table over here. So that's 2 tables we need at least, right? But we're also asked to show a couple of other things. We're showing the category description, which is in the category table, and the subcategory description, which is in a separate table, the subcategory table, right? So 1, 2, 3, 4 tables are involved. The real messy part comes with the fact that there's multiple ways that relationships run here, right? There's a direct one-to-many between category and inventory, right? In a given category, there are multiple inventory items. Also, for a given category, there are multiple subcategories. And for each subcategory, there are multiple inventory items. Woo, right? All these little lines down here. And we have to get it. Actually, there's more than one way to get the correct answer, but there's a best way as well. Okay? All right. So let's get into the actual query now. So here, we're going to actually start off. I might as well use my query design tool because it really helps with joins and so on. So we do need the supplier. We need inventory. We're going to need category and subcategory, right? Fortunately, just 4 tables this time. 4 tables should give us all that we need, right? Okay. Now, if I rearrange this so we can see the relationships a little more clearly, maybe that's a good way to put it for now. All right. Situation is that we have, right, basically foreign keys for 2 relationships here, category ID and subcategory ID, right? So how do we want to do this? Well, there are multiple approaches. Let me just start off getting the data in the projection first of all. So we have inventory ID, inventory description, next the color description, and then inventory size, supplier name from the supplier table. Then we're asked to show the category description and subcategory description, right? Now, if I were to just leave the query like this, okay, and click OK, what rule have I broken? I've told you earlier on, for the most part in queries, you never want multiple ways for 2 relationships to connect together, right? If I execute this now, I get 34 rows of data, and believe it or not, actually it is correct, right? But that's by accident, not by design, okay? Another approach, to bring it up graphically here again, kind of wish it remembered my last layout, but it doesn't, so that's okay. It's just a quick fix here. Another thing we could do is say, you know what, this relationship between category and subcategory, that's already there. We don't really need that, okay? The categories and subcategories, they know about each other. Let's just remove it. It's from the point of view of the inventory item. It knows its category and subcategory there, right? So with that simple change, now we have an easier way, and we aren't working with multiple relationships between any 2 entities. So let's click OK. Run the query. Oh, just that. Go. Go. Get away. Go. Okay. Execute that one. Same 34 rows. Have a look. And the data itself has not changed, right? But as I said, that's more by accident than anything else, right? Because the danger is, for example, right, if I were to come into the actual inventory table, okay, actually, let me make a change first here. This isn't as per, we'll have to take this out later, but let me come back in one more time. And I want to show a couple of extra things. Let's show the from the inventory table, I want to show the category ID here, and from the subcategory, the category ID, right? Now it says as expression 1. Running this, okay, I can see for each item, we have the same 34 rows. I'm just showing additional data, okay? So the category ID is 2, right? And it's 2 as well. These all match. If you check, look up and down, that's because so far the data integrity has been not enforced, but it's been maintained, right? Let's look at the inventory table itself for a second, right? Or even it's worth looking at the diagram for a second, right? Just talk about that. What prevents me from choosing a subcategory from a different category when I'm working in the inventory table, or vice versa, picking a category that doesn't match the subcategory? Truth is, there's nothing. That's a vulnerability in this design, okay? You might say, why on earth do we have both here, right? Truth is, the one that's actually needed is the subcategory ID. Because if you know the subcategory, it always knows what category it belongs to, right? So you could correctly run the query with just the relationship to subcategory, carrying on the relationship to category, bypassing, removing this one altogether. And that actually is probably the best answer to actually give to this query. A legitimate question might be, why on earth does the inventory table have both of these foreign keys? Well, that's up to the person that designed it. All I can think of as an excuse for this bad design, to be honest with you, is that for efficiency, for running, maybe they do thousands of reports and they've got, hundreds of thousands of inventory records, and most of their reports, they don't care about the subcategory, they just care about the category. So they found that it was helpful to have the category ID, the foreign key for that, so they could just do the one join between inventory and sport category for all these reports that they run, right? Otherwise, without that join, if they just had the subcategory ID in there, they would have to have the 2 joins going through this intermediate table, the subcategory table first before the category. So maybe the efficiency of that called for denormalizing the data to the degree that they're storing both. Problem is, there is no enforcement of the referential integrity within the table itself. Now, that'd be a good exercise for you to do with triggers. Every time you insert or update an inventory item, you make sure that the subcategory ID and the category ID match, right? That you're not choosing street for a motorcycle category, subcategory, if the category is apparel, as in clothing, right? And vice versa. Because I can show you if you want, but the truth is right now there is nothing enforcing that data integrity that should be there, right? So it could be done with triggers, but there is nothing there right now. So it's only because at this point the sample data we have in the database does correctly have the category ID and subcategory IDs matching, right? But that is something that could lead to problems, and that's why some answers give the same result, but some are better than others. Pardon me, I'm just really, my allergies are bad today. So anyway, all right, so I almost forget where I left off here. I got off on that tangent there. So we're showing you this. If I could prove that to you, right now we have our correct 34 rows, right? If I actually just edited a record, I could be a good instructor and create a little update command, but I can also share with you, you probably have not seen this before, edit. Now, if you have too many rows of data, you can't use this, but we don't have more than 200 rows of data, so I can come in here and I can directly edit values. So I'm going to choose inventory ID 1, this RC99 motorcycle, right? And I'm going to change the category ID okay, from 2 to, oh, I've got supplier ID there. I wanted category. Oh, no, that's in the table. Sorry, my apologies. All right, I'm going to change it to 1, which I know is apparel, right? There we go. So I've put my motorcycle here into the apparel category. Even the subcategory is still what it was, street, I think it was, right? So coming back here, if I run this query again now, look at that, okay? So they no longer match. The category ID foreign key that's in the inventory table has been changed to 1. But the 1, of course, because the subcategory is street, and as far as it's concerned, it's in still category ID 1, which is motorcycle, right? It still has a correct value. So that is now a real problem in my data, as you can clearly see, right? So that's something to think about. Yeah, sure, we got away with it because it was correct, okay, in the initial value, right? But there was nothing keeping it correct. So let me just run this one more time. So showing now they match again. That's one reason why there's more than one way to get the correct answer for now, but there's a best way to do it. All right. Long story short. So let me show you the 2 ways that give you correct answers. How many times have we revisited this query so far, right? Okay. Let me get these 2 tables back up where I can see them all. Okay. All right. So I am getting the correct answer using the 2 foreign keys, but it only is working, right? I'm going to take out these extra columns. I don't need anymore. Okay. That one. See, I can edit down here and it'll just change, and I don't need to see the category ID either. I'll get an error though if I don't take out that comma. Okay. All right. So yeah, this is going to give me the correct answer only because the data right now is valid. Okay. Another way I can always get the correct answer and be sure that I'm always getting the correct answer is to go like this. Let's remove that one and do the relationship from sport category to category. There we go. Now we're going through the X relationship, and I'll click OK. You'll see that the answer is exactly the same. Okay, same 34 rows. Okay. Oh, you know what? I should have left those in there. Hang on. Sorry, I just used undo, but I went back in and I fixed the joins the way we want them to be here. I just included those extra 2 fields in the projection there. Okay. All right. So let me run this query, this version, where I'm showing the category ID values from each table, right? So you see we are getting the correct 34 rows. All the data is correct here. But once again, I'm going to come back here and corrupt the data. I'll do the same change I did before. Okay, move this motorcycle into the apparel category in the actual inventory table. Running the query once more, watch carefully the first row. Okay, you see, this is the value coming from the inventory table. That's the one that is now wrong, but, okay, it still says motorcycles. Why? Because my join is based on the proper relationship through subcategory to category. So that is the most correct answer, even though I got the right results, okay, just going directly from inventory to each table, right? Okay, all right. Now I'm going to show you one more interesting factor. So let's bring this up once more. One other way it might occur to you to try this out, instead of going subcategory to category, you might think, well, you know what? Let's do this, okay? Let's go, as we did earlier, from category directly, from inventory to category, and take out this one. Shouldn't this work okay? Guess what? Of course, the answer is definitely no. Why? Okay? Well, we have a one-to-many between sport category and sport subcategory, right? There are many subcategories in a category, okay? Remember how joins work. Basically what we're saying is we're looking for every record where across all these joins, okay, you have matching values, right? So what's going to happen is for every category, right, if, that an inventory item is in, okay, we'll get a record, right, a row in the output. But because we've added the subcategory to the category this way, every subcategory in the category will result in a duplication of all the data coming from the first three tables. It will be repeated for every subcategory, even though it's not actually the subcategory is noted in the inventory table. Does that make sense? Maybe it's easier if we actually run the query and you see the result, right? There we go. 102 rows instead of 34 rows, right? So then you see here our first inventory item, ID 1, is repeated 3 times, okay? Women's apparel for oh, I didn't change, it still says women's apparel. Okay. But the point is, okay, it's repeated for every subcategory, women's, men's, children's, okay? Look at inventory ID item 2, the CR250 motorcycle, okay? It's repeated 2 times, okay, because there's both off-road and street, right? Our subcategories. So the same data in the first columns from the main 3 tables, it gets repeated over and over again for each of the data items in the 4th table, our subcategory table, right? So that is an absolute wrong way to configure the joins. Just before I forget, let's come back in here, put the data back so it's at least valid again. Okay, putting that motorcycle back into its proper category. Run the query again. Now you see there's only 2 records for inventory ID 1 because it is back in motorcycles and we only have 2 subcategories for motorcycles, right? If we get down to the apparel section, you'll see that everything is repeated 3 times, right, for each of the 3 subcategories and so on and so forth. Why we have 101 rows, okay, in our actual data. All right, so what was the best way again? The most correct way that will always give us the right answer? Even if the data is, as I say, not valid or corrupted, okay? We don't want to go directly from inventory to category. We'll remove that. That one can stay, but we want to go from subcategory to inventory. And that is the most correct answer that we have. Okay, we got the same results going directly from inventory to each one separately, but that was only because the data was valid at this point in time. All right, now, I guess I probably have that go at the end here. Hang on. Yeah, that's just in my, should put an extra bit of space there. Back to the correct 34 rows, showing everything we want. I have my extra columns there. I'll take those out. In fact, we do want to actually probably put in table aliases and so on as well, right? So let me just fix that up. Okay, I just put the table aliases in there. So that's good. We have our select so far, but we haven't even finished question 3 yet. Oh my goodness, I'm sorry about that. Let's come back here, right? But we want it for all inventory items where the description contains the word gloves. Well, we know that's going to be a where clause, right? So we can add the where clause. I'm just going to do it here in code. I could show you, I guess, how to do it in the query design tool. This is a case where it probably would have been just as quick and easy to do it in code, but that's okay. All right, so the field we're after is our inventory description, right? Here's our filter. So my filter is going to be gloves, but anywhere in the name. So we know the wildcard character used there, Gloves, wildcard. There we go. And so it's added that as the where clause. I could just click OK. Do we need the brackets? No. Do they hurt? No. But maybe to be more consistent with how we've probably been doing it so far, I'll go like that. Okay. So let's just check that out. Oh, like. Ha. Sorry, I did it as equals. There we are. By the way, in the query design tool, I just forgot to put the word like in front. It's just a matter of how I put the filter together there. Okay. All right. So that is the correct answer now, finally, to question 3. Oh my goodness, that was a long time to spend on one question. So let's take a little less time here for number 4. Basically, all we're doing is we're creating a stored procedure, okay, that displays the inventory list with the same fields as above. It should take a partial description value as input and then display a list of all the inventory items, et cetera, right? Okay, just decided to put the solution in here because it's basically the same query. We've just wrapped it in a procedure. I'll just take a moment. The input parameter, okay, I'm just calling it DESC, short for description. I'll mention again, I'm not super strict on whether you use the full name, okay, of description or a short form like this, as long as it's meaningful and makes sense. What I do care about, and you'll get marks for, is choosing the right data type, right? And how do I know for the description that that's what I want? Come down here, double check inventory description is a varchar 100, right? So I want to make sure it matches, and away we go. Then it's the same query. The only thing we've had to change is in the where clause when we do our like, okay, that we're concatenating our wildcard characters before and after our input parameter. And that should work just fine. So let's go ahead and create this procedure. And we'll just do a couple of tests. Okay, this is what the initial one was to give us all the gloves, okay, where gloves is anywhere in the description. Now, mind you, it's always at the end in this particular case, but that's okay. Let's try another one with leather, okay, and we see all the things that have leather in the description as well. All right, well, that basically is everything but the bonus question.